Good afternoon, everybody. My name is Colin Dhillon. I am the CTO at the Automotive Parts Manufacturers Association of Canada. Welcome to our webinar series titled Mixed Reality in a COVID-19 Manufacturing World. We're going to be talking about the importance of digital twinning and how we can unlock the true value of extended reality, which obviously covers virtual reality, augmented reality, mixed reality, specifically for the automotive sector. This is a 90-minute webinar, some housekeeping before we begin. Please keep your devices on mute. I do believe we are using a webinar version of Zoom, so I think that's taken care of, other than our panelists. All questions from the listeners and viewers should be typed in through the Q&A window. As per each presenter, so as you're seeing presentations, and there's going to be a multiple number of presentations, please share your questions throughout the webinar, ideally for each presenter as they're presenting, and I will ask pertinent questions for you as they are presenting. The webinar is being recorded and will be made available on the apma.ca website tomorrow. Welcome to everyone that's watching and listening to this webinar globally. We have people tuned in from the auto sector, global OEMs, tier ones, tier twos, academia, technology companies, tech startups, telecoms, legal and government departments and trade missions. The APMA, for those that don't know, has been representing the auto parts suppliers for over 68 years now. Our advocacy and support is in regulatory and policies that directly affect our sector, now includes support for the digitization of the entire industry, from vehicles to factories. The APMA has been leading in initiatives like connecting and autonomous vehicles, Industry 4.0, extended reality, additive manufacturing, simulation, IoT, robotics, data analytics, cloud computing, all of it, cybersecurity, making sure our members and multiple levels of government are fully prepared for what most call the largest disruption in our sector in possibly 100 years. The title of today's webinar, as already mentioned 2 times, is how can we use mixed reality, extended reality in this COVID world / post-COVID world when it comes to the manufacturing sector. You know, the importance of digital twinning to unlock the true value of extended reality for the automotive manufacturing sector. Digital streams of data and information can be expressed in many ways, on many different types of materials and in many different systems. Extended reality, which includes all those that I've mentioned before, VR, AR, MR, and more mature digital technologies, which sometimes we forget that should include smartphones and tablets. Remember, it's a software that's been developed for these realities, but the devices, the hardware that you use to actually perform or to be able to work with AR, VR, MR can sometimes be things like smartphones, tablets, PCs, and devices. When combined with IoT and analytics and driven by AI, software apps can be developed to aid your workforce. It's not a new story. You're going to be told that. Most of you that are tuning in already are aware of that. The value of XR is beyond the marketing and training segments, though, for our sector. Some of the biggest challenges that we've been facing is the lack of digital twinning in our manufacturing systems and our processes. We are still working in silos where we're using two-dimensional documents, PDFs, work instructions, for example. And when those aren't kind of digitized and brought into that same realm, it chokes the potential growth and the benefits of extended reality and going full digital. The format of the webinar, ladies and gentlemen, is for each speaker to present their visual response to the title. They will be given 10 to 15 minutes to present, and I will ask them questions throughout. Each company has its speciality and will provide intelligence to answering overarching questions like, why haven't we embraced XR at the same rate as some of us might have expected? I'm going to start to queue up our first presenter. That's Michael Gardiner. Michael works at Microsoft as the manufacturing lead, industry lead for Microsoft Canada. Michael leads digital transformation initiatives in the Canadian manufacturing industry. In his current role, he provides guidance on Industry 4.0 and helps manufacturers enhance engineering, operations, services using Industry 4.0, IoT, intelligent cloud, edge computing, artificial intelligence, and mixed reality. Michael's going to give us an overview, but let me open up the platform to Michael. Michael, welcome. Good afternoon.
Hi, Colin. Can you hear me properly?
Loud and clear, my friend.
Okay, and hopefully you can see my slideshow.
Can see your slideshow clearly as well. I'll hand it over to you.
Okay, excellent. Thank you very much, and thanks, Colin and the APMA for giving me the honor of presenting to the audience here. I'm just going to cover what we're seeing in mixed reality manufacturing, in automotive and some other sectors, and hopefully address some of the questions that Colin put out to the audience. But certainly we're seeing a lot of activity and popularity in this space. And a lot of it is around the Industry 4 journey, which is really about accelerating transformation within manufacturing using digital feedback. And that can be within your products or within your factories or operations, with your customer engagement, and certainly with your people. And so, this is typically a challenge because often these different elements of your processes are somewhat disconnected. And we're seeing with the advent of cloud and mixed reality and artificial intelligence, the ability to quickly provide feedback about, behaviors and make adjustments to your process accordingly. So if you look at digital transformation in manufacturing, there's a number of places where we see huge innovation opportunities, and there's certainly companies that are acting on those opportunities. If you look at Chevron, they're connecting experts all over the world to help their plants keep operating and connecting expertise that might be remotely. Volvo's reinventing the way that their car buyers are immersed in their experiences. We're seeing huge improvements in the factory in terms of scrap and rework, and certainly applying improved training methods and quality improvement. Supply chain is certainly a big topic these days, and more modern methods are allowing to reduce inventory and improve logistics. And certainly, mixed reality applications around innovation in terms of, the digital twin and applying 3D holograms, both, to the virtual design, but also looking at that in physical production vehicles or clay models. And the most important thing is around workforce transformation. Certainly, we have examples of Mercedes-Benz and other customers in Canada and around the world who are helping engage their employees and get them more familiar with these digital environments. And the key thing is if we combine connectivity and data and applications along with artificial assistance and mixed reality, you can kind of take your business processes to the next level. So here are some examples across industry outside of automotive. You're seeing BAE Systems or Airbus helping improve their shop floor operations and handle more complex applications. Rolls-Royce is a leader in terms of doing service or outcome-based services. And PACCAR is certainly a well-known name in the transportation industry and combining data and mixed reality to turn out their prototypes quicker. And here's an example of an automotive supplier in Germany, quite well known on the digital transformation journey. And hopefully you can hear the audio. If not, there's a YouTube video here in ZF Transmission.
ZF Transmissions is a worldwide builder of high-end transmissions for luxury and industrial vehicles.
We want to be the technology leader for automotive support autonomous driving. If I want that, I can not only have the best product, I also have to have the best processes. And I have to have the best technology to support our processes.
The passion is about bringing technology that adds value, and not just value to the business process, but value to the people. Because without the people out there on the shop floor, we're nothing.
I'm Matthias Stütz. I try to solve problems that the machines have, that they have less downtime, that we have a higher technical availability. Because if the machines are not running, we're not producing parts, so we don't make money.
I'm Lee Payton. I'm a planning engineer here at ZF's TG. I receive layouts for new equipment to come into the plant and make adjustments and then place those pieces of equipment in the plant drawing. A lot of times I have to take screenshots at specific angles so that I can get exactly what they want to see, and I have to make adjustments and really have to fill in the blanks with an explanation. And I have a difficult time trying to produce that with the tools that I have.
99% of our equipment comes from Germany and Switzerland. Either they can help us over the phone or they have to fly in. So it could be a day, could be 5 days.
The company that moves the fastest with the most innovative technology is the one who's going to come out on top.
Speaking to someone who has the same machine in Germany and has 10 more years of experience with it, you can figure out problems way more faster.
Items that I've spent hours on building come into a real-life environment, and I was able to manipulate those and change those to reflect the environment that they're in. That was a great planning.
For me, it's a sheer productivity improvement, that we bring the product out to the customer in time, in the quality, and in the cost we need.
When I can do what I love the most, and technology helps me with that, I don't feel like I'm wasting my time. At the end, it benefits myself because I'm happier, and if I'm happier, I can work better.
I'm a person of very few words. I communicate best through my creative endeavors, so that's the tool that I prefer to use, and hopefully it becomes one of the best tools that I have.
So I'm hoping that the audio came through. I'm running a couple of channels there, but the thing I really like about that example is it shows the increased worker engagement in the operations, and certainly mixed reality gives people additional tools and capabilities, because ultimately, what I found, what is true on the shop floor, is people just want to do a good job. And the key thing with helping our staff and our talent is effectively we can use data and applications to do that. So there's all sorts of different areas where you can kind of relook at how we treat our workforce, how we look at productivity, how we look at accessibility, and certainly how we look at change management. And, I see a big trend in Canadian companies and manufacturers trying to improve the engagement of their employees and use data and digital technology more. And the mixed reality is certainly a way to do that. But it's a journey, right? And it starts with getting connected and being able to see what's going on. This applies both to shop floor information systems like IoT and, your automation and so forth, robotics. But ultimately, we want to start getting connected. We want to start acting predictive, so providing assistance or being more intelligent, and ultimately getting to those outcome-based responses. I won't get into the video here, but one of the things that's certainly taken off, and this was certainly being adopted by equipment builders that are trying to support their customers with machinery in the lines. But the idea of assisting people over the shoulder, hands-free, so that they can work on complex machinery or equipment or support the uptime of those machines is something you saw an example of. And the collaboration technology is helping that happen. In the automotive industry, we are seeing this for things like training in terms of machine setup, die setup, very complex setup operations where, you may not want to be flying somebody, or you may not have the availability because skill sets are hard to acquire. And so you want to distribute that and help train people or support them remotely. We have a good Canadian partner in Cognitive Spark that has shown an example that supporting Rogers Electric and Machine. So this company actually supports utilities. Every single support call, they're saving $7,000 in travel expenses, and they're improving their productivity by between 12 to almost 70 times. So that's a huge improvement in terms of responsiveness, and certainly allows Rogers to give its customers a much better experience. So if we look at, kind of the basic level of going along this journey, remote assistance is the first step, and it's a relatively easy step to implement. But, as we want to continue and we want to develop more intelligent training or start simulating products or processes, it's going to take us up the curve. And then finally, if we want to implement digital services or closed loop feedback, we're going to need better capabilities. And this is kind of where mixed reality can help augment these initiatives. Because if you look at it, being connected means that you're starting to provide more digital teamwork and provide digital authoring capabilities. And to be more predictive and do more simulation work, what we have in Canada is we certainly have a lot of companies that have digital twins of the product. But I'd say the vast minority of companies are digitizing their process or their facilities. A 2D layout drawing is not digitization, but if you can do a simulation of your plant or of an individual work cell or of a process, this is the kind of level that you want to get to, because it allows you to get more predictive and allows you to explore, process improvements much more broadly. And then finally, if we can start to combine these skill sets together and bring in data systems like industrial IoT or apply machine learning and AI, that's how you get to more real-time responses, the idea of a self-healing process, and the idea of being able to take on outcome-based service or product models, which is a lot harder to do if you don't have those capabilities. And there's been a real recent example about this at the UK Ventilator Challenge. So in this case, a broad variety of consortium members in the manufacturing and manufacturing technology industry. Realize the slides are a little small, but you have Airbus, you have Ford, you have GKN Aerospace, you have the Catapult organizations in the UK, you have Rolls-Royce, you have Siemens, you have Thales and Unilever, and then the F1 teams, McLaren, right, along with technology providers like ourselves. And the key here is by bringing these capabilities together, both teamwork, twins, and mixed reality, it meant that they could start producing ventilators within 4 weeks. And the second design they launched a week later. So they went from zero to sourcing equipment, to setting up systems, to collaborating, to doing digital twins of the process, and ultimately training people and producing ventilators within 5 weeks of starting the project. So that's an extreme example of how fast things can be in a digital world, not only from a partnership perspective, but also a production perspective. And if we think about it in automotive, if we can take these techniques and make them mainstream in our businesses, it means that we can launch faster and much more effectively, and we can provide that flexibility that our customers are seeking. And ultimately, these all rely on collaboration and trust. So I certainly appreciate the APMA inviting me here to present today with my colleagues in the industry. And certainly, we don't have all the answers at Microsoft. We provide platforms, but we have domain experts who provide solutions like some of the things I've talked about today. So I want to thank you for my time. Hopefully I've left plenty of time for my colleagues, and I'm not sure if now's the time to answer questions, but at this point I'll end my presentation.
Thanks, Michael. Just one or two questions, and then I'll hand it off to the next presenter. So you gave that example of ZF, and it's a really good one where they're using things as basic as kind of mobile trays to move goods from one part of the line to another, and we talked about the lack of digital twins in the manufacturing process. Where does this begin? Like, who should be having these conversations? Like, why am I, let's say, as a plant manager or an operations manager, not embracing the digital twins or extended reality? What have you, as Microsoft and yourself and your colleagues, found as some of the gaps?
Well, before I worked at Microsoft, I've been in the industry for a long time, at a pretty prominent German engineering firm. But what I found in Canada was a big gap is probably the education and the training on the digital technologies. And I know that's changed quite a bit recently, but traditionally in engineering programs, we were teaching engineers how to use CAD and do design work of the product, but we wouldn't teach them simulation and digital twin work of the process, right? And I can say that in Germany, that education is mainstream, and I've certainly tried to be involved and make that more mainstream. And there's certainly some educational institutes in Canada that are adopting that. But I think that is probably the #1 inhibitor is the availability of training and skilled graduates. So that's kind of the pipeline of talent that we need. Now, it doesn't stop companies from taking up this technology, and that's certainly happened. I know a lot of world-class Canadian companies doing that, so they took the initiative. And I think one of the key takeaways from ZF is the attitude of the management there being supportive of these, and I think that's really important. I think that's the key to adopting this. We got to, talk the talk and walk the walk.
Thank you, Michael. Next, I'll ask Ajay Sinha from WIPRO to prepare. Ajay is the consulting head for engineering and design services for WIPRO. As head of WIPRO's engineering design services, Ajay brings over 24 years of core experience in new product development. Before joining WIPRO, Ajay spent 12 years in the automotive industry in product strategy, design, and development. He is currently focused on product strategy consulting, enabling additive manufacturing, vision for the customers, and implementation of digital twin, leading Industry 4.0 for clients across industry domains. Ajay is based in Washington, D.C. Good afternoon, Ajay.
Good afternoon, Colin, and thank you so much for providing this opportunity to be on this forum. And I see very good participation here, so thank all the participants across the globe who have joined. Thank you so much, Michael. I think it was very enlightening to see the kind of technologies which you talked about, which are taking this journey forward. And I would be taking that discussion forward by talking about how do we enable this mixed reality in current environment. So while the things kind of look very futuristic, but the way we are seeing it is very coming very close, and you have seen even the example how this technology has enabled some of the things in a very, very fast manner in current situation as well. So I'll for the people who are not familiar with WIPRO, I'll give a quick backdrop. WIPRO is a global IT services organization with more than $8 billion revenue, 1,000+ active clients, 180,000+ employees worldwide with operations in 59 countries. We also have large presence in Canada with 1,100+ employees and offices in multiple locations. And one of the lesser known facts is that WIPRO has more than 10% of revenue, which comes from the R&D services. So we are close to providing the product design, simulations, testing, all these services as well. And also we have world's largest third-party hydraulic cylinder manufacturing facility, which is working for the industrial and aerospace and multiple clients, and they have the manufacturing as well, right? So from that perspective, not only the IT, but we have the length and breadth of the engineering as well as the manufacturing as well, which we are trying to bring together for our clients. And while doing that, another aspect is, from engineering side, we took a look at the technology stack which is available and saw that which are the technologies which are kind of disrupting the landscape, and it impacts all of us. So starting with artificial intelligence, wherein we have our own HOMES platform to machine language, machine learning, 5G, blockchain, Industry 4.0, IoT, and security. So all these are various technology levers, and the way they are affecting in various scenarios, like you are seeing the increase in terms of the media and entertainment, the expectations which are there with customers through that mobile experience is basically seeing the same experience elsewhere in your workspace as well, right? So that is where I think some of the topics which we are covering today, like the AR, VR, mixed reality, or immersive experience, kind of become very, very handy in terms of providing that kind of collaboration, that kind of experience to our customers. Similar things in the automotive industry, we are seeing that the connected vehicles are becoming a reality in a very, very fast pace. And again, a lot of this is getting powered through the connected cloud computing. And even in current scenario, you have seen that a lot of workforce from even engineering had to work from home, which was unprecedented, but the industry was able to step up and provide those solutions to enable a lot of these collaborations happening. So while these technologies are there, and it could sound that some is applicable for one particular industry, but the way we see it, that all of these are interconnected and are impacting all the industry segments together. So, and particularly for today's scenario, what I'm seeing with the manufacturers is there are a segment of customers who have seen very sudden demand, and putting a complete pressure on the supply chain to enable the increased production, or there are suppliers who have very less demand and they have to shut down the plants completely as well. So idle capacity is there. So there is one side to that. The second thing is that the social distancing and the remote working are, though we thought that it is going to be a short-term thing, but the way we are seeing it could become a new normal, and there could be extended, precautions which we may need to take in our work environment, and which may limit some of the things which we used to do in a certain way, right? So there also we need to bring more resilience into our work environment. We need to provide more secure or cyber resilient environment for our employees to work on. And last but not the least is that another thing which we saw is sudden closure of borders, right, which has not happened, and suddenly you're not able to leverage the global sourcing and things like that. So we are seeing the advancement of technologies like 3D printing as alternate way to manufacture closer home. So these are different challenges which we are seeing, and a lot of these technologies which we are talking today, digital twin, additive manufacturing, cloud computing. So all these are something which can help in current scenario, as well as will be helping in future working environment or new normal as well as we go towards that. So without further ado, let me take a digital twin and how it enables mixed reality. And as Michael spoke really, of the three different aspects. So one is basically getting connected, which is the fundamental layer in which basically you are getting the data foundation, monitoring, or the data visualization part of it. And then taking it to more of predictive and cognitive layer, right? So we find that there are some organizations who have moved on this journey, while there are many customers who are very intrigued by these technologies, but at the same time do not know the right way to proceed on that journey. So let me cover that how we see that being enabled, right? So the most of the common use cases which we see, people see that remote maintenance and other solutions which are there in the market. But the use of this mixed reality, we are seeing across the product lifecycle. So basically starting with the design, in which design creation reviews by the R&D teams sitting across the globe are able to participate and together review the designs which are there. They are able to annotate and provide their comments or change certain parameters on the fly. So all these are happening on the design side, while in the manufacturing, you're able to see a lot of the configurations, the way you want to do, you want to change, you want to use that plant for some product in a particular week or month, and then suddenly you have to change it to another product. And you're able to do that much ahead of time, and even all the work instructions and other things can be done using this mixed reality framework. We are seeing a lot of contact less sales, which has started happening. So even the product demonstrations, branding, marketing, and of course the training of the people who are joining in the manufacturing organizations, or it could be at the dealership or in the warehouse, wherever they are, right? So in order to train them, a lot of these foundations which we create can be leveraged across. So apart from that, the more popular use cases which you have seen is the operations, the way you perform certain functions through, or perform the maintenance through remote assistance, or through the mixed reality frameworks. So all these are different solutions which are helping you leverage the resources which are available in diverse locations, and with much more reduced travel, much more optimized way, first time right, or captivating product demonstrations, faster learning, and higher productivity. So a lot of benefits are there. However, for your organization, the basic fundamental thing which you need to start is having a strategy on how you are connecting all this data, because so far the things were kind of being done in silos. The R&D organization will be working and then providing that data to manufacturing. From manufacturing, it will be produced, will go to sales and marketing, will go to dealerships, and then to the end user. But however, the need is basically to connect these various dots so that they start talking to each other and start giving feedback. And that is what is the base for the digital thread, or digital twin. And while that looks like a very big word and looks like a mammoth exercise, but we find that if you are able to look at holistic scenario the way you are operating currently, wherein you may be designing the data and then the as-built data, as design data is available. And then manufacturing or plant operations is producing that. And here you see the product is there in the market. So the way we are seeing that once you start connecting this end product, through the IoT technology, basically you are able to leverage a lot of parameters, which you are able to pull in and see vis-a-vis, the normal curve which you had in your design curve. So basically you are able to see that what is the actual cycle in which my product is running, and you are able to see if it starts going off normal curve, can I do predictive maintenance to reduce the downtime, or can I feed in this data to the upfront design cycle so as to make the other products much more robust to be able to withstand those different user data which is coming. So that is one way in which the parts or the products digital twins are seen. However, today I'm focusing more on the process side of things, wherein you have the manufacturing plant, and right now once the product data comes, you may have a lot of processes in either the Excel files, or you have PDF drawings or the work instructions, which are many times need update on a frequent basis as the product changes, and many times it is not done. And that becomes a bottleneck for you to operate. You're not able to see that suddenly when the demand or other things change, how will you cope up with that, right? So in order to support these kind of challenges, basically if you are able to pull all this data from your manufacturing plant into virtual environment, in the form of a digital twin or a virtual replica, and then run all these simulations, what if scenarios of how, if I change this demand from today's 10,000 parts to nearly 100,000 or a million, then what is going to be my need in that? If I want to change the layout, if I want to change the flow from semi-automatics to a fully automated flow, what is going to change, right? So all these are different things which you can run in virtual environment, and then use the same, for change impact assessment, or even use it as a proving ground for some of the newer technologies which you want to incorporate, much ahead of actual implementation. So these are multiple things which are possible by using the digital twin. And the good thing is that many of these tools and other things which are there in the which are enabling creation of digital twin are able to leverage a lot of different forms and shapes in which data comes. So we are able to pull in all that data to form a digital twin. And of course, if it is not connected, it will require some effort. But I would like to share, some of the examples in which people have used, and I think that will throw some light as to how, different companies have started leveraging this data, right? So basically, once you have this data into the virtual form, basically the complete layout planning, the way, you may have grown organically and, started utilizing machines or adding machines or product families as you went. But at the same time, if you want to have a look whether that was optimized or not, and you want to make certain changes, all that layout planning, the process planning, the capacity or throughput analysis, logistics planning, so all these things are something which can be done using this platform, right? And once you have, this, simulation available, basically you are able to go to the level in which even if an operator is carrying certain part which is like a heavy and he has to put from one place to another, how much effort that operator is going to take? Will it result into any fatigue or anything or safety issues for them, right? So we can go to that level of detailing on this, right? And once you have these simulations available, you are able to cut out the same, for creation of 3D work instructions. You are able to use the same videos for, offline training to your employees who are joining and who need to, start work so they can get trained much ahead of time. You can use the same videos or the simulations for the downstream mixed reality applications, like the operator going for the remote assistance and all. So all that work which you are going to do to make this connected and create simulations is something which will be very, very helpful in terms of driving the mixed reality adoption in your organization, right? So we have done multitude of these implementation across, aerospace, automotive, consumer goods manufacturers, and even semiconductor manufacturers, so multiple places. I'll take one or two examples probably to demonstrate how this works so that you are able to visualize better. So basically you see this is one example of the aircraft assembly, which is generally very different than a fully automated plant, wherein you have few stations and the parts basically come on these stations at various times to create that assembly. So only these workstations kind of move closer to that assembly and then move away, right? And also these red and blue lines which you are seeing are the tuggers which move to deliver the parts real time, right? So all that is something which we just needed the process flows, some of the 3D data, which is more of skeleton data, not the internal details, and we are able to create all this simulation. And it can be used for multiple things, basically understanding how the process is working. If the wingspan of these aircraft is changing, will that result into any clash anywhere in the process? How do we need to make these workstations where they will be initially, when they will come, how they will come. So all these aspects you are able to take. So we used this 3D simulation for that purpose, while the other part in terms of seeing whether the tuggers are properly balanced or not, for that we use the 2D simulations, right? And this is something which is very interesting because if you have your plant, you generally have AutoCAD data available, you have the processes available and everything, and you can take all that into account and create this kind of views and see that how the process is working. Like for example here, if I run this simulation within minutes, right, it will run for the complete cycle and tell me whether various matrix, whether these different tuggers are optimized or not, right? So we can tune all this leveraging the data which you have available, and data comes in various forms and shapes, from Excel files, the exact timestamps and other things in which the parts were supplied earlier and things like that. So we leverage that, we map it, calibrate all the data once, and then we start running that, right? And once we have the calibrated data, we start running what if scenarios on top of this. So then you are able to see that the two tuggers were not optimized, and we were able to balance the two by moving some parts, by doing those combinations. And then once they were optimized, we optimized the route, and based on that, we were able to reduce the tugger delivery time by nearly 15%, right? So this is one example of how the companies leverage this as a technology. I'll take one more example, which will be closer to you because many of you are coming from the automotive industry. So this is an example of a plant wherein there were two lines, which were, this plant manufactures electronic stability control modules and are global leaders in that. So They, from this particular plant, they were producing nearly 6 million parts, while the installed capacity was around 9 million. So there was a gap in that, and the team themselves came up with an idea that if we introduce buffer system between two lines, because they don't seem to be balanced, would be a good idea. However, the budget and all for that was not getting approved because they had no mathematical proof that this will definitely increase the production, right? So we took that as a problem statement and went ahead and did the complete mapping. And again, though the plant was completely automated, the MES was running, we were getting a lot of data, but still the processes were all over the place. We had to pull in a lot of that data to make this a complete connected virtual environment. But once we run this, we were able to prove that after 150 odd parts of buffer, it is not really helping you increase the yield. So you need to have some other methods to do that. Right, so with that, they went ahead and implemented this solution. And with that, two things happened, right? So one is they got the justification to go for that buffer system, which they wanted. And second thing which happened is they proposed 1,000 parts buffer system, and we reduced that to 1/6 of the cost, right? So that, again, was a key factor here, right? So these are the kind of things which you can see, and I have a number of examples, but in the view of time, I will just run to two of these. So there are multiple of these examples which we have done across, like the warehouse, wherein the complete stacking of parts, how you are delivering that or stacking them, and then how you are picking them, and everything can be assisted using mixed reality. Right here in the example, also you are seeing that using this, he is able to see which order from which what component he's supposed to pick and deliver against the order, right? And even the smart field assist solutions. So these are multiple examples in which once you have the basic foundation of digital twin, you are able to take it forward for the implementation of mixed reality. So with that, I will take a pause, and if there are any questions, Colin, I'll take that.
Thanks, Ajay. We're a little over time, so I'm just going to make a comment based upon one of our listeners, viewers, John Wright, talked about how the aerospace sector has been a leader in simulation digital twin using mixed reality, driven mainly by economics and risk, as the old style physical prototyping became too expensive, too time consuming and dangerous. So again, some good insights there from those that are listening and watching, and thank you very much for your presentation, Ajay.
Thanks, Colin.
Okay, so as we prepare our next call, there is a method to the whole madness. You started with Microsoft providing us a kind of an overview of where things are in the industry globally. And then we talked about an important key to this, which is digital twinning, to be able to kind of, change and kind of smooth out some of those silos and connect them. And so, there is cost saving opportunities even for the automotive sector if you embrace and make the, the investments earlier. Our next speaker is Michael Sagan from Autodesk. He is the Technical Solutions Executive for Automotive and Research Catalyst in San Francisco, California, USA. Michael is part of the Auto Tech account team, working with customers around the world. As one of the subject matter experts on generative design, he has collaborated on wide-ranging projects from cars to aeroplanes. Prior to joining Autodesk in 2015, Michael helped to launch products for 20 years in diverse industries such as architecture, consumer electronics, home automation, electric motors, tools, and toys. Michael's going to provide us an overview with tools for manufacturing, supporting collaboration and working remotely through the cloud. He's going to tell us about their advancements. And listen, we didn't plan for everyone to be holding hands on this panel and singing Kumbaya, my Lord. It's nice to see how Microsoft and WIPRO are talking about, other software and technologies. Ajay mentioning Autodesk, that wasn't in the script. But Michael will tell us about generative design phase 2, called Design 2D. Michael, I hand it over to you. Good afternoon or good morning.
Good morning. Thank you very much, Colin, and thanks to the other presenters. And I wanted to start with an acknowledgement of the very present thing that's in front of us. And it's not COVID-19. It's the fact that the 21st century is here. And just as a reminder, there's about 80 or so years left, depending on how you do the math on this. And so, yes, we're facing massive disruption right now. And we've done this before. We've faced massive disruption before. And we can talk about any one of these particular massive disruptions on the screen that I've got listed. In the interest of time, we won't. I will talk about this, though, because it's really important as we look at the present landscape of today. What did George do in the future? George went to work. If you know the cartoon from the United States, George went to work for 1 hour a day, 1 day a week in that future. And so that's predicted for 2062. So keep that in mind as we think about flying cars. And the thing that I want to mention about flying cars is how close are we going to get to that? If you look at something a little bit closer on this timeline, Uber Skyport is predicted for 2028. And so that's really interesting when you start to think about convergence and the way people are going to social distance and the way they're going to work and design these things. Think about that for a second. The other thing I want you to think about and take away from today is, are flying cars really going to be a thing? What are we going to design in the future as it comes towards us? It's coming whether we like it or not. And if you look at what Morgan Stanley says, they're saying that it's going to be about a $1.5 trillion industry in 2040. So goodness only knows what's going to happen in 2062. And so what I want to talk about a little bit about like contemporary things that we're doing. In 2015, we started working with our technology centers here at Autodesk to figure out what that future looks like. And one of those things is the generative design and how to work and collaborate together. And this inspired one of our residents at our technology center in San Francisco to work on an autonomous vehicle. And think about that for a second. If you're going to do that, if you were a Ford from 100 years ago, you do that very differently than you would today. They started, our friends at Technology Center, PIX Moving, they started with 5 people from 5 different countries, and now they've grown to 35 people, and they're working out of our Technology Center spaces. And it's a very different way of working. And what they're doing is using automation inspired by a project that we did in 2015 to figure out what those future vehicles are going to look like, leveraging VR, AR, robotics, and all of those things. They're putting that future in place right now. And so they're actively doing this with us in our space. And so it's a really interesting project. And I want to share with you a little bit about how these tools come together. My slides are automatically advancing for some reason, Colin and everyone else. So that's why I keep switching back and forth. I'm not sure what PowerPoint is doing. We'll always have these technology disruptions, whether it's PowerPoint or software or AR. So I want to give you a little context here. So if you look at this 2x2 matrix, if you can see through it, I've got on the horizontal axis, hardware dependence. And on the vertical axis, I've got the type of work that you're doing. Are you doing design work or are you doing high-end visualization? And so if you're looking towards the left and you say, look, I need a little bit of hardware dependence, as others have mentioned. I want to be on the cloud. I want to be on a mobile device. Maybe I could get away with the Fusion 360 product from Autodesk, because that is designed for the 21st century. Some of our other products, which are amazing at surfacing and advanced design and visualization, were designed 30 plus years ago, and they're not written for the cloud. And so you have to think about in terms of hardware dependence, how are you using hardware? Do you have a VR set at your desk? If we took a poll, I wonder how many people have VR or AR or MR hardware at their desk. And that would be an interesting data point, Colin. At one of these junctures, we'll talk about that. So I want to dive into Fusion 360 a little bit, and then I'm going to talk about VRED and Alias, and then how we collaborate and use these tools and support different technologies as we approach the 21st century. So Fusion 360 started about 5, 6, 7 years ago. It really became commercialized. And Autodesk said, let's rewrite for the 21st century. Let's have cloud integrated product development teams working simultaneously on a lightweight form factor, and answer those questions, what if? And so when we started back in 2015 with our what if question, like Ajay said, what if you could do this? Well, one of those questions was the Hackrod project. And I want to bring it up because it was an automotive example of two things. One, both concept software that Autodesk developed to take advantage of future manufacturing platforms and the ability to use and leverage different techniques to manufacture. And that's something that we predicted would happen. And if you fast forward to today, it is happening. Back in 2015, we used a technology called generative design to develop this project. Some of you may have seen it and been potentially inspired by it. And it was an amazing project to work on. And it really just let us get at some of these fundamental questions. How does a separate team with 20+ people working on a particular project like this work together? And so from a platform perspective, we were able to use a Mac. We were able to use a PC. We were able to use a tablet. And we weren't really worried about AR yet. But we were worried about collaborating. And that's one of the strengths of Fusion. If you look at this screen, it's just several of the tool sets and environments inside of Fusion 360. If you look at the left, you're looking at all of the different data that you can store. And when you do this, you're sharing it up on the cloud. And that's really important because as all of you know, how do you know where the file is? How do you know what the latest version is? And how do I work with other people outside of just emailing? We're using a Dropbox or something like that technology that was really designed for the time. So in looking forward, Fusion's combined several things together to get at these design paths. If you look in the middle box, we have design, generative design, like I said, didn't exist in 2015 as a real tool. It's been integrated as of 2018, 2019. We have a render workspace, and as others have talked about, a simulation in space is very important to know how to validate what you're doing before you make those investments into product development. And that's all integrated in front. And so we even have a manufacturer space. And of course, I want to talk about generative design specifically. The what if for this project was, what if 3 kids in a dorm room could produce a chassis that was 200 pounds lighter than the existing chassis, and how would they do that? Well, we were able to do that with this technology called generative design, and the cloud solves that it does. We set constraints. One of the constraints was what the skin was. The designer gave the project the skin to work with, and then we literally grew a 3D printed titanium chassis into this car. And what's important about it is generative design, leveraging the cloud, goes out and solves for hundreds or thousands of conditions based on goals and constraints, based on data. And the data, as others have mentioned, is super important to know what to solve for. And so it's going to introduce a new way of thinking about manufacturing in the future. And how do teams work together to make better design decisions? So here, even cost is considered now in generative design technology. And so we can say, prescribe a specific manufacturing constraint like additive printing or 2D milling and ask for results based on particular material characteristics, all based on data, all solved in the cloud, and get many, many results to jumpstart that what if process. And again, just as a reminder, that's what led us to this. We had to do this manually back in 2015. It took us a year to get from 2015 to 2016, where we said, let's use a readily available manufacturing process in welding and tube and truss structures to be able to make something like this. And what was really important about it is we could save it to the cloud. People in England could work on it. People in Canada could work on it. People in the United States can work on it. And that was really a game changer. And it's led to the technology developments in Fusion 360 today. And that's that kind of that lower end, I'm using the word out of context. That's why I wanted to give you the context of a lower end. It's not lower end. You're using a regular computer and you're leveraging the cloud. So what happens when you want to move up the design curve and say, I want to do more one-to-one scale and take advantage of some of the other tools in the portfolio of how to visualize and how to design and create? Well, in automotive in particular, it's very important for people to view one-to-one scale. And that's where Alias and VRED come into play. And so this starts to move up that continuum of hardware dependency. You start to need more hardware, you start to need different types of headsets, and virtual reality comes into play in this area where we have the ability to schedule a meeting in Outlook, of all things, with your extended design team and have virtual avatars participate in the design. And then you're able to use the controllers to laser point and to have conversations, to interact with the design. And you can even have a spectator mode where people can observe and understand how users might use the design or interpret a new design release. So as was mentioned earlier, the entire user experience is going to change as we have more and more access to hardware and software. And so I wanted to specifically mention Windows Mixed Reality as one of our supported hardware devices. We're able to use these devices very fast to be able to take advantage of this piece of hardware. And this is where how much hardware do you need? How much setup do you want to do? All of those things, and that's why I would love to know who's using which hardware or who's using hardware at all and in what configurations, because this is so new. And again, 80 years left in the 20th century. We started working with Microsoft back in 2015 on the HoloLens. And so where does that take us into that future? It's very exciting how all this technology is going to change, a very exciting time. And so I want to mention two other things about VRED, and then I'm going to show you a couple things with what VRED can do and how to collaborate. It's not enough to have the hardware. What if you wanted to stream? And with VRED, we can stream within a virtual area network or a VPN, virtual private network. We can stream a set of data to a web browser. So you don't need to host it's a different configuration of hosting the data where we're not going to the cloud. And I'm bringing this up specifically because of security. There are concerns in the world about cloud security, and we take them very seriously here at Autodesk. And these are other ways of dealing with well-known and established criteria to be able to stream into virtual reality and using the VRED. And so here's an example. If you can see, depending on how choppy the video is, a multi-user collaboration session, which is very different than what we were talking about with Fusion 360. You're able to teleport and interact with a very high fidelity model. And I do apologize, there's nearly nothing worse than watching a VR session through a PowerPoint played movie on the internet streaming. And so depending on your tolerance for your bandwidth and the tolerance for that, please permit the choppy video that I expect you're seeing. All of the tools in VRED are designed for interaction, where very simply you can use custom menus, set up custom scenes, custom paint, and really have that collaboration where somebody in Germany or somebody in Japan or somebody in North America could really have a really in context conversation about what's happening. And we support Zoom for voiceover. We even support internal voice as well. And just looking at that whole manufacturing workflow, we're able to get to a sign-off very much more quickly and with the higher fidelity that you would have in a more disconnected process. So it's not a complete replacement, but it's certainly something to pay attention to as we look into this future. And that's what I really wanted to talk about with our tool set and how it relates to data and collaboration. And to answer any questions, I went through to try and catch us back up on some time there, Colin. So if there are questions, perhaps we could talk about those.
So while Colin's looking at questions, I just want to jump in and do a mini little plug here. Michael Sagan mentioned the Autodesk Technology Centers a little bit earlier on. We are currently also keen to engage any innovation groups who are looking to develop projects that have anything to do with the future of work, post-COVID-19, how might work evolve and change. And so if anybody is on this call is looking to do that, please visit our website, autodesk.com/tech centers or technology centers. And you can Google it, you can find it there, and submit a proposal or reach out to us. Thank you.
Thanks, Vanessa. Yeah, Michael, I think, you know, generative design 2D, you know, the next phase, when we all saw the first images a few years ago of that seatbelt bracket, you know, made, you know, X amount % lighter, X amount % with less components, it got us all thinking. And so, you know, maybe kind of, you know, tell us a little bit about, because again, it's all connected. We're using digital twinning, we're using data, it's a collaborative tool. Tell us maybe a little bit for a minute or two about maybe the new 2.0 version of generative design from Autodesk.
Sure. Yeah, I'll give it a little baseline context again. Thank you for the opportunity. So when we first started doing this, we really looked at unrestricted manufacturing options 5 years ago in order to get the algorithms right, to get the machine learning right, to get the data right. And now, over the course of the last 5 years, we've added 6, 7, 8 different manufacturing types: laser jet cutting, investment casting, 2.5-axis machining, 5-axis machining. And so we've evolved, as we've grown with the tool, the different manufacturing types that make sense. In 2015, it didn't really make sense to print a full car chassis 3D printed titanium. That would have been bananas. However, in our what if scenario, it gave us enough runway and enough opportunity to think about how we could use that jumping off point to move that product forward. And so that's what we've done, as we've learned with the integrations with the other Autodesk platforms of how we can pull in bits and pieces to get at those manufacturing techniques that normally were an email or an FTP site away. Now they're in an online collaborative environment where we can have a digital exchange with commentary back and forth. And so it's really important to be able to get, especially now that in the last 6 months, we've really added costing. It really makes those design decisions really interesting now, because all of those what ifs become sort of more real, and we're compressing the timeline in ways that aren't still understood by many people, including us. People will use these tools in lots of ways, and it's exciting to see all the different configurations that come out. And as Vanessa mentioned, especially exciting at our technology centers, where we can work together with customers and people to explore these new options.
Thanks, Michael. And for those that are watching and listening, I don't know how we got so many Michaels all on this same webinar. We were joking, Michael 1, Michael 2, Michael 3. I now move on to Michael 3, Michael Rosas from Virtualware, VP of North American at Virtualware. Michael is a promoter of future innovation, a diehard and early adapter who is passionate about helping like-minded entrepreneurs and executives create the biggest impact for the clients when they serve, who they serve. As a VP of Virtualware North America, Michael's mission is providing businesses with clear strategies on how to level up their collaborative designs and training environments to stay ahead of the curve in today's global connected dynamic landscape. Michael is going to be talking about, amongst other things, their immersive intellectual property, their IP, some of their technology. So in this COVID world, we are all locked in our living rooms, our kitchens, our studies, our basements. But at some point, we need to collaborate using the digital technology to be able to work with colleagues, you know, and so, you know, I'm hoping Michael's going to be able to share more on this immersive experience with their case study. Michael, good afternoon.
Hello, everyone. And first of all, I want to thank Colin, Eyal, and Flavio for inviting us to be a part of this timely webinar. These guys have been busting their butts to bring everybody together in this industry. So during this very confusing, critical moment. So just want to give gratitude that they continue on fighting the good fight for all of us now and in the future. Which brings us to why we are all here. Now that we are close to 2 months into this current COVID crisis, we can start to see some patterns of what life will be like in the short term and what it may not be, or maybe in the future, not so distant future. So we've been asked to talk about actual use cases using technology that exists now to get mobilized in getting ready for the future of work. and how we go. So, and the truth is it has been already developing for years. And now with everything going on, the idea that companies can wait to transform their operations into an integrated and digitally connected world economy just isn't much of an option anymore. So with this in mind, we asked our peers in the industry, what would be the most important things that they would need to make this jump, especially now with current challenges we face? The feedback we got was very valuable. Most people are looking for virtual solutions that are more efficient than their previous workflows. Solutions that could cut down on time and money spent, all while putting the power in the hands of their team to actively grow the business without physical and distance limitations. And that's why we came up with the Virtualware Immersive Room, also known as VRED, that enables any organization to launch one-to-one scale multi-user virtual reality content by means of patented technology and software platform. I'm going to share a video right now so you can see it.
Virtualware has developed VRED, Virtualware Immersive Room, a unique and complete turnkey solution consisting of two key elements: the hardware, equipment, and technology, either powered by Immerso technology or integrated with third-party technology, and the necessary software package. This software package, called VRED Suite, enables organizations to generate and update content in a simple way after having some basic training.
All right, well, with this solution, we've been able to meet the demands of our clients through these 5 key points. So VRED is a solution that is scalable. You can go as big as you want to suit the size of your team needed to tackle big tasks. The reasons for this, unlike previous technologies, that our patented locators can be installed in common T-grid ceilings. You can kind of see them in the background there. So as you go along, you can set the immersive room to live just about anywhere in your operations. This solution is also mobile. The patented technology's form factor means your immersive room is mobile and can move to where your company needs it most, whether it be for training, design, or the marketing for your products. It's also a solution for free roam. At an enterprise level, limitations should only be set by your team's imagination. That's why we've created a solution that allows you to collaborate with others on a massive scale. Just like your business in the real world, you want to include everyone, whether it be 20 to 25, 30 people. And we've not only made it inclusive for departments to work together towards one goal, we've also designed it for remote collaboration. This means that you can work alongside with your teams, whether they are here in Canada or in other locations in the US, Mexico, even Europe and Asia, collaborating in a 3D environment where you can move around your designs and manufacturing plants physically and interact tactically with your actions. And finally, it is affordable. It's about 2/3 the price less than similar options on the market right now. The technology is most recent available, so efficiencies in hardware and software that is available at the moment is something we could take advantage of as well as scale for the future. So let's go to how this may apply to you. Let's start with design. Our technology allows you to inspect every aspect of a car's component virtually and walk and sit in it and make adjustments based on visceral feel of the vehicle, much like what a customer would go through in the process of testing and choosing a car. The biggest difference here is that your design team has the ability to do a collaborative at a one-to-one scale, working with each other on each and every change, creating an efficient workflow to make refinements necessary to get design just right, so that your part goes to production and has already been tested vigorously to be the best in its class. This means less time and money is spent, as you don't need to create expensive physical mock-ups. It also cuts down on the time your team needs to troubleshoot and comprehend new complex design challenges. All this together allows for an acceleration of what can be done in a project, getting you to market faster. I'll share you a quick video here so you can kind of see how this works. All right, and so you saw a little bit about there. That was one of the installations that we have already up and running. Now I want to move on to how this works for HR and training. Our solution has provided clients a cost-effective way to level up with their teams, stay on top of not only new regulations, but also new processes. And these new ways will work together digitally in a digitally connected world. The big thing we saw was a need for a solution to cut down on the expensive time and money companies take on to train their teams in physical replicas. The image you see here is of a project we did for General Electric Hitachi that has combined cutting-edge XR technology and OEM know-how to develop a bespoke fuel movement simulator. I'll show you a quick video in a bit to see how it works. Before that, I want to touch upon the particular use case, as they have reported that they are saving about 70% a year in travel and living expenses other than their previous training system. And that's not taking into account that the building of a physical mock-up for this kind of training would cost them around $5 million to produce each time, along with having a permanent physical location to house it. VR technology is great for training beyond money saved, as retention of information and know-how from a full-scale virtual replica really helps the team members immerse into complex scenarios and problem solve viscerally. As you can see in the box that he's handling there, that's the actual device in the nuclear fuel mover machine, which integrates perfectly into the virtual world, allowing it for tactile feedback and training that is as close to reality as possible. Here's a quick video of how this particular use case works. And that's basically it. We wanted to show that we have the virtual tools available to us now to make that transformation that a lot of people are looking to do, and we are here to share them with you. If you want to hear more about this, we are doing a webinar in May, about mid-May, so you could we can go deeper into sort of these solutions and how they could potentially work for you. So you could reach out to me either on LinkedIn or check us out on our website. So I just wanted to thank everybody. If there's any questions, that'd be amazing, but thank you very much.
Thanks, Michael. I think we should have a few minutes at the end for some general questions to the whole panel. So, but thanks for sharing the details. You know, I wonder why we do even greenfield manufacturing building without going into VR first, what I just saw there on the last clip. What I'm hearing, and it seems to be a pattern, is cost savings. We saw, a huge percentage saving at the first presentation. You're talking about saving huge amounts of money when it comes to some training for human resources as well. So, yeah, absolutely. There's a lot there, and again, this kind of thing that we could definitely go in deeper. We'd love to chat with everybody who has questions about this and how it could actually be effective for them. Thank you. Okay, next will be our friends, family members, as we would like to call them, from the Windsor ECDev region. Ed Dawson from IBLS is a mobility analyst. Ed works to support the region's quest in pursuing mobility technologies that will shape the future of what the next generation of infrastructure and vehicles will look like. especially as they relate to crossing international borders. And he's also the lead on the Windsor's region's immersive cave. He will be supported in this presentation by Akash. Akash is actually extremely new to the organization. Akash is the virtual reality cave operator at the Institute for Border Logistics and Security in Windsor. Akash's primary focus is to provide technical expertise to businesses and academia in understanding the capabilities of their VR cave and working to spur innovation by helping to kickstart potential projects. Akash brings over 8 years of professional experience in the automotive product design sector. And we are going to hear now from this team who, again, I mentioned them as family. That's because we're all a part of the Autonomous Vehicle Innovation Network run by the province and the OCE. Ed, take it away. Good afternoon.
Good afternoon. Thank you very much, Colin, and obviously everyone at APMA. You guys have been tremendous. Thanks for incorporating us and obviously your leadership in the COVID-19 crisis. Just to give everyone a bit of a background, IBLS is the Department of the Windsor-Essex Economic Development Team, and we're focused on automobility, technology, and innovation. As Colin mentioned, our contributions to the AVEN network revolve around cross-border technologies and simulation testing with respect to connected and autonomous vehicles. We very much wanted to complement the work that is being done by our AVEN family and the demonstration zone, of course, led by APMA. The creation of the VR Cave allows advanced simulation testing for CAV product development. This is, of course, complementary to the live test beds that exist with our partners and that are deployed. And our ultimate goal is to help participants save time, save money, and to obviously test in the safest ways possible. The VR Cave actually launched on May 28th, 2019, and has generated a great amount of interest. Since then, we have conducted over 85 demonstrations to a variety of students, professors, and of course, companies. Aside from the sheer wow factor that the cave presents, the biggest challenge that we've identified is that interested parties are not familiar with the specialized hardware and software that power the environment. So because of this, we knew that having a full-time VR Cave operator would help bridge the gap between ideas and having these assets fully utilized. So through one of our partners that helped bring the VR Cave to life, Simutech Group, we created a full-time position to take care of the VR Cave and to help with this. So our newest team member is Akash Charuvila, and he came on just within the last month, as Colin mentioned, and he's been spending his time doing a lot of virtual learning and obviously getting ready. So by the time COVID-19 subsides, we can definitely hit the ground running. So I'm now going to turn this over to Akash to tell you more about the VR, especially the cave and what we're working on. So go ahead, Akash.
Thank you, Ed. Thank you for the introduction and good afternoon, everyone. I've been told that we are short on time, so I'll skip through a few slides that have already been discussed in the webinar. So I'll jump directly into the VR cave. So why the VR cave? The VR cave essentially is an immersive physical space. It's something similar to the V room that Michael mentioned, except for the fact that instead of a head-mounted display to show the virtual environment, we use a system of projectors that project images on 3 walls on the sides and 1 wall on the floor to give you a physical space where the user can walk around and interact with virtual objects. The biggest advantage of the VR cave is the wide field of view that it offers as compared to a head-mounted display. It gives a field of view around 170 degrees as compared to 100 degrees that a head-mounted display can offer. And because the user, all he does is wears a glass that's similar to a 3D glass that you wear during a 3D movie screening, the user is you're free to move around completely in the space, and the trackers on the user's glasses would track his position and adjust the image accordingly as he moves around the space. And the glasses allow the user to interact with other people in the same space. As in the case with head-mounted displays, they are completely isolating, and it's very difficult to interact with other users while you're using the headset. But in this VR cave, because it's not completely isolating, you can conduct meetings, and the biggest advantage of the VR cave is the collaborative meetings that we can conduct in the space. Multiple users can use the space, interact with data, interact with data, look at 3D complex 3D models, and interact with them naturally on a 1:1 scale. And because this, the screen is so large and away from your eyes, it's really comfortable for extended usage. You can see on the right, the image shows the virtual reality cave here in Windsor. And the smaller image, you can see my friend Ed interact in the VR cave. He's actually looking at a 3D model of his favorite sports car under different light conditions. He can walk up to it, walk around in the space, and look at it at different angles. And this is a technology that we wanted to make it mainstream. Avon, who's our key funder, funded this project so that we can provide this technology to small and medium scale companies based in Ontario for the advancement of connected and autonomous vehicle technologies. This site is one of 6 such sites that Avon has funded all across Ontario, and all these sites collaboratively work on CV and AV technologies. Also, if the companies qualify the requirements set by Avon, they can use the space free of charge. This space can also be used by researchers and students as a learning tool to advance their education and further the research on virtual reality and augmented reality. And we are proud to say that this is the largest publicly accessible cave in the whole of Canada, specifically for the testing and design of CV and AV technologies. We have partnered with ANSYS, who provided us with the software for simulation. Simutech Group provides us with the technical expertise required for simulation, and Barco provided us with the high-end 3D projectors required to build the cave. And with these partners, we are able to deliver advanced simulation capabilities, including manufacturing simulations. Simulation, something that Ajay mentioned during his digital twin presentation. We can definitely have virtual trainings similar to the V-Room. And we can also have perceived quality evaluations because we can simulate different light conditions and observe the product under different light conditions. And of course, we can definitely do simulations for autonomous testing, ADAS technologies. And we also have a virtual drive simulator where you can simulate various driving conditions. We realized that it would be a challenge to reach out to multiple companies across Ontario because the cave is located in Windsor. So we partnered with TELUS, who provided us with some Cisco WebEx technologies, and together we created a cluster of cameras that allows the cave to be viewed remotely, and thus we can reach to multiple companies all across Ontario, and more so ever after the COVID-19 phase. We believe that this would be a very big advantage in our pockets. Another program that we're running is the digital twinning program. As Ajay mentioned, digital twinning is a very powerful tool, but what we have noticed that the biggest challenge companies face is the research and development support needed to adopt these technologies. So with funding from FedDev Ontario, we launched the digital twinning program. This program is directed towards companies who want to adopt these technologies. And we, along with St. Clair College, Canadian Association of Mold Makers, and Automate Canada, plan to provide the required research and development support to companies to adopt these technologies. The goal for us is to have 10 companies on board to participate in the digital twinning program. So far, we have 7 companies who have already onboarded, and 17 companies have expressed interest. So we are well on track to meet our target. So the goal here at IBLS with the virtual reality cave is to provide access to technologies, and also provide research and development support to companies to adopt these new virtual reality, mixed reality technologies, and to aid manufacturing, which more so than ever is the need of the hour. We are interested in working with companies, and if you can reach out to us on our website, and I can take some questions. Thank you.
Akash, Ed, thank you very much. And a thank you to all the panelists. We still have approximately 4 minutes, so I'm going to ask a few of the questions that have come in and a few that I had prepared. Feel free to open up your mics and whoever kind of says and speaks first can go ahead and answer. I may only have an opportunity for one person to answer one question. 5G, folks, 5G. You know, the thing that's brought COVID, apparently. Jokes aside, the second coming for all technology. How important is the speed of 5G and its bandwidth going to be for extended reality? I throw it out there.
That's a great question, Colin. I don't have the full answer, but I have to say that edge technology is also important, at least from an industrial standpoint. So not everything, but like certainly in public spaces, I think you'll see you know, in things like autonomous driving and things that were previously disconnected will be connected. So that will affect the accessibility, I guess, of these types of technology.
Okay. It was a larger question from somebody in the audience. I'm going to try and wither it down. Again, as we embrace the digital world to realize these benefits, we should also remain mindful that this digital environment is just a facsimile of the real world. The integrity and reliability of these facsimiles are essential characteristics for the user community in terms of efficiency, profitability, sustainability, and product liability. How do the panelists rate the maturity and integrity of the products and services they offer, maybe by using the trusted Six Sigma yardstick? So where are we at when we try and bring it up against the Six Sigma when we talk about extended reality? Anyone?
That's a tough question. I think, I mean, the processes, I mean, a lot of the simulation and digital twin products are based on physics and mathematics, the same that you'd use in the engineering process. So I think it's more an examination of the process than the technology. I mean, in terms of reliability of these types of technologies, usually you're looking at 5 or 6 sigma just in terms of uptime, but then there's fault tolerance and high availability and things like that that can also apply. So I'm not sure if that's the nature of the question.
Well, let me position it this way to maybe Ajay and WIPRO and the example from aerospace. The virtual model that you showed of the assembly of an aircraft, what are some of the bottlenecks or some of the negatives or some of the issues you faced or the company have faced still, even though they still use digital twins and they use this facsimile of reality? Like, you know, can you share any that you may be aware of?
Right. So basically, you know, the simulation is dependent on the quality of data which is being fed in, right? So the more you can, you know, simulate the real life situations, the more you are able to document the same, create those scenarios or exceptions in the process, the more realistic it becomes. And more than the aircraft solution, which is more like I would say a slower process. In the example which I talked about in the automotive world, when, you know, millions of parts are produced, so there also we were able to correlate the data to you know, taking a months of data and then trying to run the simulation. We were able to correlate to a few parts level, right, by incorporating all the data. But the important thing was they were capturing nearly 95% of the data through their MES systems and other things, which we were able to feed into this, right? So the short answer is the quality of these simulations or digital twin depends on how good your data capture process is, right?
Thanks, Ajay. And just one last kind of question going back to the title, the importance of digital twins and mixed reality, extended reality to unlock the true value of the in the automotive sector. What are we seeing? Are we progressing? Have you seen progression, folks, over the past few years? Is it stagnating? Where are we heading? Again, crystal ball, a few seconds, anyone?
So I'll take a lead on this, Colin. So basically, you know, last couple of years, we have seen a lot of interest from the organizations in terms of learning what it is. There are different charters getting created in terms of Industry 4.0 or, you know, through Digital Twin Initiative. You know, multiple forms and shapes it is coming, but we are definitely seeing a lot of interest, a lot of experimentation around this. Automotive sector, I would say, and even the aerospace are the two most advanced in the space who have done a lot of adoption here. They have started utilizing, not to the true extent, but it is a journey, right? So they have started using or leveraging this technology ahead of others, I would say, and the other sectors are yet to catch up on that. But still a large sector of automotive, I would say more so tier ones and tier twos are yet to adopt, but they need to.
Okay, well, again, Michael, Ajay, Akash, Ed, Vanessa, thank you all. It's been enlightening. We will be having more in the series here at the APMA. We are embracing Industry 4.0, as some of you know, and this is just one of the segments. So thank you very much. And for all of you that did tune in, thank you very much. Have a great afternoon, evening.